Consider the following model for active monthly users of Snapchat given in millions. So the number of users is equal to this function here, which is the logistic function, where we're given the parameters A, B, and K, and T is given in months after November 2011. If we look at some of the statistics, it says that Facebook receives roughly $1.33 per month revenue for every monthly active user. So if we assume that Snapchat will have a similar revenue, let's estimate the revenue that Snapchat will generate for the next 5 years, starting in January 2017. Okay, so it's asking for the total revenue for the next 5 years. So what we'll do is the first thing that we need to do is we need to figure out a function for the revenue as a function of time. So the users are given here by this logistic function, and it says that for every monthly active user, Snapchat would make approximately $1.33 per month. So we're going to call this little r of t. So this is monthly revenue. And what that is going to be equal to is 133 times the number of users times the number of users, which is equal to 1.33 times b over 1 plus a e to the negative b k t. Okay, so this is the monthly revenue as a function of time. So suppose we plugged in t equals 1, that would be the monthly revenue after 1 month. If we plugged in t equals 2, that would be the monthly revenue after 2 months. We could even plug any non-integer number for t. For example, we could plug in t equals 0.5, which would be the monthly revenue at half of a month, or we could plug in t equals maybe 1/30th, which would be the monthly revenue calculated after 1 day. So this gives us an idea of what the monthly revenue for Snapchat would be at any given time t. So in order to calculate the total, of course, the revenue is changing as t changes. Every minute, every second, every nanosecond that goes by, the monthly revenue changes. So what we're going to do is we're going to divide up the next 5 years into different time intervals. So this would be, say, the month January 2017, which is 62 months after November 2011. So we're going to start out at t equals 62. This is January 2017. And what we're going to do is we're going to chop up the next 5 years. So this would be January 2022. And what we're going to do is we're going to chop it up, which would be 122 months. T equals 122. T equals 122. And we're going to chop it up into a whole bunch of time intervals and sample what the revenue is at all these different times. So this would be T1, T2, T3, and so on. And we're going to go all the way out to January 2022. And we're going to evaluate what the monthly revenue is at that given time. So and we're going to chop these up into equal time intervals. So each of the time intervals is delta t. So these little time intervals are all the same size, even though the drawing doesn't look like it. They're all delta t. And so the total revenue is equal to the revenue at t1 times the amount of time that goes by, plus the revenue at, I guess we should start at t0 maybe, times the revenue at t1, times the delta t, plus the revenue at t2, times the a little bit of time, plus so on and so on and so on, all the way up to the final time, the revenue at tn times delta t. So we're going to chop this up into n pieces, and then what we're going to do is we're going to sample the monthly revenue at each sample time, and we're going to multiply by the length of time in between, because this will give us then essentially the total revenue over that time period. So this would be the total revenue over the first time period, this would be the total revenue over the second time period, third time period, and so on. So we're going to chop it up in n time periods, we're going to add them all up. So the total revenue is not equal to, but actually approximately equal to, so I should actually have an approximately equal to sign, because of course the monthly revenue over any one of these time intervals is not constant. As time changes in between these time intervals, the revenue is also changing. So, of course, the revenue isn't constant over these time intervals. So, the total revenue in each of these time intervals is not quite this. But we can, if we make the intervals really, really small, we can kind of approximate it this way. So we're going to sample the revenue at all these time intervals, and we're going to multiply by the length of time in between each time interval, and that will give us more or less the amount of revenue that Snapchat will make over each time interval. Of course, this gets better and better and better if we take the number of time intervals to infinity. So we chop it up into more and more pieces, and this is actually equal to, so the total revenue is actually equal to, so if we get this not approximately equal to anymore, but equal to the limit as n goes to infinity of r of t naught delta t plus r of t1 delta t all the way down, just like we did before, all the way down to r of tn times delta t. And of course we recognize this is a Riemann sum, and this is the limit of a Riemann sum, and we know what this is. This is the definition of an integral. So the total revenue going from t equals 62 until t equals 122, so that's over the next 5 years, is this revenue function r of t. It's given by the definite integral from 62 to 122 of our revenue function. So this is the total revenue. Of course, with knowing the fundamental theorem of calculus, we can then say that what we'll do is this is exactly equal to the antiderivative of our revenue, which I'll call capital R, evaluated at 122, minus the antiderivative of our revenue function evaluated at month 62. This is just the fundamental theorem of calculus, where the derivative of R is equal to our monthly revenue. So what this is saying is that capital R is the antiderivative of little r. So the only thing that kind of remains is us to figure out what this capital R is, what this antiderivative R is, and then plug in our endpoints. So if we look up here, this is our R of t, so we're going to have to calculate the indefinite integral of this thing. So that's the only piece left in this puzzle, is we need to figure out what R of t is. R of t is the indefinite integral of R of t dt, which is equal to the indefinite integral of this function here. This is our monthly revenue function, so this becomes 1.33 times b, so this is just our little function r, 1 plus a e to the negative k b t, and we're going to integrate with respect to t. Of course, we can simplify this. This is just a number, this is just a number, so we can take them outside of the integral. This becomes 1.33b, and then the integral of 1 over 1 plus a e to the negative k b t, and integrate it with respect to t. So now we have to actually calculate this indefinite integral here. So let's go ahead and do it. This is equal to, if we keep going, we're going to do a little bit of a clever trick here. If you didn't kind of know this clever trick in advance, it'd be pretty hard to actually figure out on the fly, but because we know it, we're going to use it. What we're going to do is we're going to make our integration easier, we are going to multiply the top and the bottom of this integral by e to the positive kbt divided by e to the positive kbt. So all we're doing here is multiplying by 1, because e to the kbt divided by e to the kbt, of course that's just 1, but we're going to multiply our function by this. Kind of seems silly to multiply something by 1, but what we end up finding is that this will actually make our integration simpler. So now we have the indefinite integral of e to the kbt, that's all on the top, because 1 times e to the kbt is of course e to the kbt. And then down here, if we look what happens, this e to the kbt will multiply this 1, so this becomes e to the kbt, right? Because e to the kbt times 1 is just e to the kbt, plus, now look what happens here. This becomes a times e to the negative kbt times e to the positive kbt, and these two things, the negative version and the positive version, cancel out and just end up being 1, so at the end of the day, this just makes it plus a. Okay, it kind of seems weird that we would think about doing that, but what this will allow us to do is actually do a much easier substitution. So we're going to now take this integral here, and we're going to do the substitution u equals a plus e to the k bt, which means du by dx is equal to, if we take the derivative of this, it's just kb times e to the k bt, which means that dx is equal to 1 over kb e to the kbt times du. So all we're doing is a substitution method with this as a choice of u, and so if we go ahead and do that, what we end up with is, so this is kind of off to the side, what we get for our integral is, we now have our integral e to the kbt, that's just going to stay there for now, e to the kbt, and then this is going to be divided by u, because this is our definition of u. I used some x's here. I should have used t. So this should be a t, of course, not an x. This is a t. And then this is also a t. So our dt is actually this now. So we can replace dt by this. It's 1 over kb e to the kbt. And some here I lost, somewhere along the way I lost our 1.33b. So that's out front of both of these, 1.33b, that didn't go anywhere. Okay, so after the substitution we have this now. This is quite nice because this e to the kbt cancels out with this e to the kbt, and what we're left with is now just 1.33 times b times the indefinite integral of 1 over u du. And then this kb I'm going to take out and just going to be here. So this kb comes out because these are just two numbers, remember, so they can come out of the integral. So I'm just left with an integration that looks like this. This b can cancel out with this b. And so if I continue right along here, this becomes equals 1.33 divided by k times the indefinite integral of 1 over u du, which we know is ln u. Knowing that, I can then go back and change this, what I know about what u is. We know that u is, actually, sorry, that's the log of the absolute value of u. So if I just plug u back in here, we have 1.33 over k, logarithm of the absolute value of, what is u? A plus e to the kbt. Of course, this, a is a positive number. It's about, what do we say a was? A was 390.5811. And this exponential is another positive number. So a positive number plus a positive number. This is just another positive number. So at the end of the day, our antiderivative after this clever indefinite integration just ends up being 1.33 over k times the log of a plus e to the kbt. Okay, so that's capital R. So what was the point of doing all that calculation? The point of doing all that calculation was, if we remember, the total revenue, because we define it as a definite integral, the total revenue is this antiderivative R, which we just calculated, at 100, t equals 122, minus this antiderivative at t equals 62. So we can actually, now that we have the function capital R, we can go back in and say the total revenue is equal to R, which is this function here, evaluated at 122 months, so it will be 1.33 over k times the logarithm of a plus e to the kb times 122. So we've plugged in 122 in. So this is R of 122 right here. We've plugged 122 into R for t. And then we're going to subtract, because our total revenue, our definite integral says we now subtract capital R evaluated at t equals 62. This is going to be 1.33 over k times the logarithm of a plus e to the kb, and now we're evaluating this at 62. A plus e to the kb, and now we're evaluating this at 62. And if you now plug in all of the numbers, so we know what k is a number, we know what a is a number, we know what b is a number, so if you plug all of those numbers in and ask a calculator to do this for you, what you find out is that the answer is equal to 30319.4. Now, interestingly, we have to remember what this number represents. So these users were in millions. So R of t here is in millions of dollars. Millions of dollars. Okay, so the monthly revenue is in millions of dollars. So after doing all of this integration, the result is also in millions of dollars. So this is millions of dollars. So the answer then is approximately over the next 5 years, according to this model, Snapchat will make $30.319 billion, which is a lot.